Now let's talk about the ocean currents, what happens at the surface of the ocean. So first of all, we know we have winds blowing above the surface of the ocean, and we know that there's a fairly good connection between the prevailing winds, the easterlies in the tropics, the westerlies further north and south between 30 and 60 degrees, a link between the winds and the ocean currents. And the winds are actually pushing the surface water. You know, if, for example, you take a fan and you blow a fan on top of a bathtub, for example, the water will go to the one side. So the same in the atmosphere and the ocean, the winds which are blowing, the easterly winds which are blowing constantly in the tropics, push the waters towards the east. And you can see here on this map, the red arrows show what's happening in the atmosphere. We've got the easterlies in the tropic, the northeasterlies, the southeasterlies, and then as we go further north from 30 to 60 degrees, we have the westerlies, and the blue arrows show what's happening in the ocean. So in the tropics, the waters are getting pushed towards the west. In the higher latitudes from west to east, the only difference is that in the oceans, we have boundaries. We've got borders. Unlike the atmosphere where the air can keep on going across the continents, in the ocean, we have boundaries. So when the water, which is in the tropics, goes from east to west, it eventually hits the Caribbean, the United States, and has to go north and produces the Gulf Stream. And water which is going from the United States to Europe eventually hits Europe and Spain and has to go south. And therefore, in the different ocean basins, we get this circulation patterns, these circular circulations we call gyres, like from gyroscope. And these are flowing and basically following the wind patterns in the different parts of the globe, in the different oceans. And we look on a global scale, you can see that these gyres, which are following the wind patterns, are going, again, in the northern hemisphere, they're going clockwise. So in the North Pacific, North Atlantic, you can see that the pattern of these gyres in the ocean are going clockwise. In the southern hemisphere, they're going anti-clockwise, counterclockwise, in the opposite direction. They're pushed initially, again, by the winds. So in the tropics, we can see that the currents are basically going from east to west. We have the easterly currents also in the ocean. Higher latitudes, we have the westerly currents going in the opposite direction. And then, because we have the boundaries of the oceans, we have these north-south currents which have to connect up and produce these gyres. But by the color of these arrows, you also see that depending on where the water is coming from, it'll be either warm water or cold water. And so if you look closer here, you'll see that the tropical warm water is being transported towards the poles, always on the western side of the oceans. So we have here, for example, the Gulf Stream, which is taking warm water up to the polar regions. We have the Brazil Current, which is taking warm water south. We've got here the Agulhas Current, which is taking warm water to the south, and so forth. But on the other side of the oceans, we've got, to close the gyre, we have the cold water, which is going up along Namibia, the Benguela Current. We have the Peru Current, which is cold. We have the cold current along California, the Canary Islands. And so basically what the oceans are doing again is mixing the water, taking the warm water south or taking the warm water towards the poles and bringing the cold water back down again. So the roles of the ocean is really to mix the water always, taking the warm water to the colder areas, bring the cold waters back to try to reduce the temperature gradients on the planet. Now, when we look at the effect of the wind on the currents, again, the water will start to flow in the same direction as the wind, which is directly above the ocean. But again, we have Coriolis force. So if we have currents which are going over long distances, the direction of the water current is going to start to change. And again, in the northern hemisphere, this example, we're going to get the deviation of the water currents at the surface, which are going to start turning to the right of the wind direction. You can see the surface current in the white arrow. But that top layer is going to push the water underneath it, and that water underneath it will be turned also to the right of the original flow of the water. That will affect the water below it. And you can see we get this spiral we call the Ekman spiral. after a scientist named Ekman, that as we go deeper in the water column down to say 100 meters, we start to get this rotation, the spiral of water, which is turning towards the right relative to the wind direction, again for the northern hemisphere. And if we take this whole column of water, say 100 meters, and we see what direction is that column of water moving, we get this big arrow over here, which we call the Ekman transport, where the whole column of water is being moved to the right, 90 degrees to the right of the direction of the wind at the surface. So this occurs if the winds are blowing over long distances and in the same direction for a long time, for days, for weeks. The direction of the wind, we'll see that the water underneath it, the column of water, is moving to the right, to 90 degrees to the right of the wind in the northern hemisphere, and 90 degrees to the left in the southern hemisphere, because Coriolis force is in opposite direction in the southern hemisphere. So how does this affect the temperatures in the ocean? Well, if we look at this example, for example, along the coast of California, where we have the winds coming from the north, what happens is that the column of water, 100 meters underneath the winds, will be diverted 90 degrees to the right of the wind direction. So basically the water is being shown by these white arrows. The surface water moves away from the continent, and you cannot be left with a vacuum there. So what happens is that very cold water gets sucked up to the surface, the dark blue arrows, in a process we call upwelling. The water gets upwelled, the cold water from the depths gets pulled up to the surface because the Ekman transport is taking the water away from the coastline, and this is because of the winds which are blowing from north to south in this part of the world. And if we flip the wind, so the previous example, again, we can see on the top, because the winds are coming from the north in the northern hemisphere, we get the transport of the surface waters according to the white arrows, and this brings up the very cold, deep water to the surface, a process called upwelling. And this is why along the California coast, Peru, Namibia, we have cold waters coming up from the depths close to the coastline. But if we flip this, theoretically, the winds are blowing from south to north now in the same location, again, the Ekman transport is to the right of the direction of the gray arrow, and so the water will be going according to these white arrows into the continent. And then again, when it gets to the continent, the water has to go somewhere, and so it goes down, and a process we call downwelling. So the upwelling is when the water is kind of pulled up, the cold water is pulled up to the surface. Downwelling is when the warm water at the surface gets pushed down into the depths of the ocean. So why is this important? Because the cold water which gets brought up to the surface, and here you can see the coast of California, a lot of organic matter and plants and animals die, and when they sink to the bottom of the ocean, there's very high concentrations of nutrients in the deep ocean, but there's no light. And when we get this process of upwelling, of the cold waters coming up to the surface, they bring lots of nutrients, phosphates, sulfates up to the surface, which is the food for the plants, for the phytoplankton, microscopic algae to eat and to grow. And here we can see a picture on the left is a visible image where you don't see much. If you look very carefully, you may see a difference in the color of the water because we have lots of algae and phytoplankton here. In the right, we can see in a different color, looking from a satellite, different part of the spectrum. This tells us something about the concentration of chlorophyll in the ocean. And this along the coast of California, because we have so much nutrients being brought up to the surface, we have thriving, the biological activity, both the phytoplankton, the vegetation, and that's the food for the zooplankton and all the different fish in the ocean. We have very rich biological activity here because of this phenomenon of upwelling, which is driven actually by the surface winds blowing across the surface. Another example of this upwelling and downwelling we can see related to the monsoons. So we already spoke about the monsoons, and during the summer in India and in this part of the world, the winds are blowing towards India, bringing the rainfall to India. But if we now see what's happening in the oceans, Ekman transport is to the right of the direction of the wind. So the Ekman transport has to be 90 degrees to the right, which is pulling the surface waters into the middle of the Atlantic, which means we have this cold, nutrient-rich water rising up here by the Arabian Peninsula, and we have the very high biological activity, lots of phytoplankton, lots of fish there. In the opposite season, in the winter monsoon, the northeast monsoon, the winds are going in the opposite direction, and now we're having the transport to the right, but into the land, which causes downwelling, and we see a very different picture when we're talking about the amount of fish in the ocean and the biological activity. Today, fishermen actually follow this kind of data from satellites, and whenever you see these areas of upwelling, you know there are lots of fish there, and fishermen actually can use this to plan their fishing season and when they go out and where they go to catch their fish. So if we look globally where we have these areas of upwelling, you can see here that, again, the winds are shown in the gray arrows. So we have here in the tropical areas, we have the trade winds shown in the gray, and the dark blue arrows show where we have these upwelling because the water is moving away at the surface, moving away from the continents, generally on the western side of the continents. So California, Peru, Ecuador, Canary Islands, Namibia, Australia. These are the areas where we have the upwelling in the ocean, very rich in nutrients and lots of fish, and also very cold, the water, because the water is coming up from the depths. So this fills the surface waters with very cold temperatures. And we can see that here on this plot of temperature. So the color here is actually temperature going up to 35 degrees, the surface temperature of the oceans. And you'll see, first of all, we obviously notice that we have the warmest temperatures in the tropics, similar to what we saw earlier, the maximum solar radiation in the tropics, and it's much cooler in the polar regions. But if we look from east to west, we see differences in the oceans that off the coast of Namibia, Peru, Ecuador, we have much colder water than we have on the other side of the oceans, and the Canary Islands, California. And this is because of this phenomenon of upwelling, bringing the cold waters up to the surface. So on the eastern side of the oceans, like here in Namibia, the temperature is much colder than on the other side near Brazil on the same latitude. And this difference, the east-west difference, is basically driven by the winds in the atmosphere, which are driven by the rotation of the Earth. So when we go back and look at the desert, the distributions of the deserts, we said they're basically at 30 degrees north, 30 degrees south because of the Hadley circulation. And so we have the sinking air at 30 degrees. But if you look a little carefully here, you'll see that most of the deserts are again on the western side of the continents. If we look at the Namib and the Kalahari, here in Patagonia, also in the United States. And this is because we have another factor which is affecting the desert, and that's the cold ocean currents. When you have cold water, you don't have much evaporation, you don't produce clouds and storms, and so generally the deserts occur on the western part of the continents around 30 degrees because of the effect of the temperature of the oceans.